So let's go ahead and do the next example, and we're going to do the 5-step strategy to graph the polynomial function. Remember polynomial, and we're going to look at a degree more than 2, we have the degree of 3. The first thing we do is look at the end behaviors, and the first, we look at the leading coefficient test. And it looks like my degree is odd, so n is odd. And my leading coefficient is positive. So I'll look back at my leading coefficient test. And again, this will be next to you when you're doing your work, of course. The n was odd and leading coefficient positive. So n is odd, leading coefficient is positive, so it should fall left, rise right. Fall left, rise right. Fall left, rise right. So falls left and it rises right. That's what it looks like the end. The next thing you want to do is you want to find the X-Intercepts. That the polynomial equals 0, so I have 0 equals x to the third minus 3x squared. We'll call the GCF. I get x squared, I get x minus 3. That means x equals 0, x equals 3, but the 0 has a multiplicity of 2. Because this is x times x, and then each of the x's equals 0. Then we have the multiplicity of 1, because this 0 only occurred once. Okay. So at this 0, 0, we have 0, 0. It's going to go ahead and touch and turn around. So it touches and turns around. And at this 0, since the multiplicity of 1, it's an odd multiplicity, it's going to go through the 0, 3 zeros. So it goes to that 0, 3 0. So go through that point. Okay. Then we want to find the X-intercept. I mean the Y-intercept. The X-intercept. We're going to put in 0 in for x. We get 0 to the third power minus 3 times 0 squared, which is 0 minus 0, which is 0. My Y-intercept is 0, 0. Then we're going to go ahead and see if we have symmetry. The original function was f of x equals x to the third minus 3x squared. I put in the negative x in. Okay, this becomes negative x third minus 3. This stays x squared. So it looks like it changes, this term changes sign, this one doesn't, so it had no symmetry, the neither symmetry. Remember, it has to either all change signs or they all stay the same. Okay, and the fourth thing I want to do is look at turning points. The max turning points. So the degree here is 3. So we did 3 minus 1, which equals 2. So this should be 2 turning points. Let's go ahead and see what our graph looks like so far. And we might need more information in just a second. We'll go ahead and graph this. You know, on the exam, I'll give you some graph paper, of course. Okay, so we know we have intercepts of 0, 0, and 3, 0, 1, 2, 3. And we know that we have, at this 0, it's going to touch it. It's going to either touch like this and come back, or touch like this and come back. And at 3, 0, it's going to go through it. So it can go through it that way or that way. So how do I know what's going on? Well, look at my end behaviors. It's going to fall left and rises right. So if it falls left, then it should do something like this. Okay? And it rises right, that should do something like this. Okay? It's kind of a sketch of what's going on. Not perfect. We have no symmetry, so right now it looks like it doesn't have symmetry, which is fine. and max 2 turning points. So what I'm looking at here is I know that at this point this should come back down because it's going to touch that 0. At that 0, you said here it touches and turns around. So we know it should come back down here, and then it should come back this way. But I have no idea where it should land here. Does it do this? Does it do this? I have no idea. So what I'm going to do is I'm going to go ahead and try to find a point somewhere down here to kind of give me a guide of what's going on here. So I'm going to find out what value of y I have when x is 1 and x is 2. So I'm going to go ahead and do f of 1 and f of 2 and see what happens. Okay, so at 1 I have 1 to the 3rd power minus 3 times 1 squared, which is 1 minus 3, which is negative 2. So I get 1, negative 2. So 1, negative 2 is going to be a point. And then I've tried 2, I get 2 to the 3rd power minus 3 times 2 squared, which is 8 minus 3 times 4, which is 8 minus 12, which is negative 4. So I get 2, negative 4. If you really want to, you could do f of 1.5 and f of 2.5 to get a better idea of what your graph will look like. And I went ahead and did that. F of 1.5, I get 1.5 comma 3 point, or negative 3.375. I do 2.5, I get 2.5 comma negative 3.125. So these first 2 points are going to help me draw a better graph. So 2 and negative 4 will be down here. So it looks like my graph is going to look something like this. I'm going to write this. It's kind of weird there. Okay. So if we look at this carefully, do you notice I have 2 turning points, like I said I would. There's no symmetry. My X-intercepts are 0, 0, and 3, 0. At 0, 0, it touches it and turns around. At 3, 0, it goes through it. Now, if you actually want to be a little bit more accurate, you want to figure out where this goes, you could even do f of negative 1. See what happens there? I get negative 1 to the 3rd power minus 3 times negative 1 squared, which is negative 1 minus 3 times 1, which is negative 1 minus 3, which is negative 4. So negative 1, negative 4, I can actually erase this, get a better graph. So negative 1, negative 4, what about there? So that's a graph of my polynomial function. Okay, let's go ahead and do the next example. I hope I have enough time to do it. Let's go through the 5 steps here. And the first step is the leading coefficient test. So I have, here I have n is actually odd because I have 2 plus 1, so the degree is 3. Remember how we add the 2 plus 1, so the degree is 3, so n is odd. And the leading coefficient is negative. So n is odd, and leading coefficient is negative. N odd, leading coefficient is negative. Okay, n is odd, leading coefficient is negative, so it's going to rise left, falls right. Rise left, falls right. Okay, rise left, falls right. So rise left, falls right. Again, we don't know what's going on in the middle there. Okay, so it's going to rise, left, falls right. Okay, they're going to find the X-intercepts. We'll plug in 0 and 4y, so 0 equals negative 2x minus 1 squared, and then x plus 2. So it looks like that actually done most of the work for me because they've already factored it for me. So x is going to equal 1 or negative 2. And this is going to be a multiplicity. The 1 is a multiplicity of 2 because this factor occurs twice. So x is going to equal 1 twice. This is a multiplicity of 2. So we have 1, 0, and a multiplicity of 2, which means it's going to touch and come back and turn around. If 1 is going to be negative 2, 0, and have a multiplicity of 1. So it means it's going to go through it. Okay. Then we're going to find the y-intercept. Plug in 0 for x. I get negative 2 times negative 1 squared times 2, which is negative 2 times 1 times 2, which gives me negative 4. I get 0, negative 4, my y-intercept. Okay, now here at possible symmetry, now let's go ahead and sketch what we have so far. You could plug in the negative x into here and see what goes on, but it's going to be a little bit harder to find out what happens. You have to multiply it all out and so on. If you really want to find symmetry, you would multiply all this out, get your polynomial, and then put your negative x in and see if it stays the same, changes, and so on. We're going to sketch what's going on here. We're going to save ourselves a little bit of time here. So right now, I get an idea of what we have here. Now I have 1, 0, and negative 2, 0, 0, negative 4. Look at it carefully. It looks like there's no symmetry in terms of y-symmetry and the origin symmetry, no. So it looks like there's no symmetry. The symmetry appears not to have any. So instead of putting that negative x in, it's a little bit easier to do that. Okay. Let's go ahead and find the max turning points. My degree is 3, so I have 3 minus 1, and I get 2. So 2 turning points. Let's see what's going on here. So we know that it rises left and falls right. So it should do something like this. Rises left and falls right. Now we know we have max 2 turning points. It looks like it's going to have to go here and something and then turn back up. We don't know where. So this is where we look at and go, I have no idea what's going on in the middle here. I don't know if it comes here and connects into that. I don't think it does. I know that this point right here has a multiplicity of 1, so I know it should go through. This one has a multiplicity of 2, so this one should come back that way. So now it should do a little bit of this. This one should go through. Again, I have no idea what's going on between there. So I'm going to go ahead and see what happens at f of negative 1, f of 0 we already know, and see what's going there. Okay, so f of negative 1 is going to equal negative 2 times negative 1 minus 1 squared, and then negative 1 plus 2, which is equal to negative 2 and then negative 2 squared times 1, which is negative 2 times 4 times 1, which is negative 8. We get negative 1, negative 8. I'm getting ready to end my video, my time limit here, so it's not a really great stopping point, so we're going to pick right back up to here when I start my next part. So we found out one point what happens right here, what happens in other places, so we'll start there in the next video.